Hi, I'm Travis. This is Handcrafted Overlanding. And on today's Will You Ever Get a Dang Project Completed? That's the goal. Get a dang project completed. If you remember on the last episode that I made, I was waiting on parts to mount the Dewalt 618 router. The problem that I ran into on that last episode was the spindle clamp was 100 millimeters and the diameter of the 618 is like 89 point something. It's 3.5 inches on the nose. So I mentioned that I was going to have my uncle build it, make it for me because he has a 3D printer. Well, I forgot to ask. Now, I know he would have gone and done it if I just asked, but he was in the middle of a project. Dude is working on some really cool stuff. I didn't feel like I should bug him. So I set out to find my own spacer for this. So while looking around, I noticed that the inner diameter of ABS plastic pipe is actually what it says it is. So I thought I can go find myself a 3.5 inch ABS pipe that would handle the inner diameter, and I could mill the outer diameter down. There's a problem. 3.5 inch ABS black pipe is not readily available, at least not in my area, and not from what I could find online. You know what has an outer diameter of 3.5 inches? A 3-inch ABS pipe. You might be wondering, how does that help you? Well, there's something that actually mounts to the outside of a 3.5 or a 3-inch ABS pipe. It's a coupler. So all I had to do is I had to come in, and this little ridge that keeps the pipes from sliding too far when you're gluing them up, I took my dremeled that out, and boom, fit like a glove. My next step was bringing the outer wall diameter down, and I think it was big by maybe a millimeter, maybe 2 millimeters. Anyways, I started sanding it, did not work. I started scraping it, my hands cramped. I went back to my trusty Dremel with my carbide cutting bits, and I just went around a few times until it slipped right in. I then cut a slot on my table saw. That's an 1/8 inch gap, which is more than enough. And what you have is a really nice fitting mount, and it doesn't have any play in it whatsoever. So to all my friends out there with a 90 millimeter router or a Dewalt 618, I think Bosch also makes something along the same lines too. But those of you who don't want to go spend $119 on a dedicated mount for this particular unit, you can go buy this guy, which is at the time it's probably like 35, 40 bucks on eBay, which is better than 190, and then a 3-inch ABS 3-inch coupler. I bought two because I figured that I was going to miss the first one up, but I didn't. Anyways, so that's done. My next goal is going to be limit switches, which I will also be trimming the screws at the same time. After that, wiring. After that, everything in the box. And I'm hoping, without too much delay, I can make my first pass on this, because there's a lot of tweaking that needs to go on, and I'll get to that later as we get to it. Anyways, let's have fun. And welcome back to another lovely day. So now it's time to wire up the electronics into a box. This box is going to be mounted to the side of the CNC table. You guys are going to see more of that when I actually get to mount it. It comes with these mounting hardware. I'll figure that out later. But right now I kind of wanted to show you everything that's going inside the box. So we have our 24 volt power supply. We have a 24 volt to 12 volt power converter, or excuse me, no. This is a 24 volt to 12 volt power converter. This operates off of 12 volts. This is for our fan controller for our 2, eventually 3 80mm fans. These came out of a server in my office that are super duper loud, but they move a lot of airflow, so it's going to keep everything cool. Those are going to be wrapped up in these screen meshes. What I'll probably end up doing is I'll probably find a way to attach some fabric. I have some fabric screen material that's 1 micron. Of course, we have the black box that we're going to mount inside here. Now, this is not decidedly a Raspberry Pi. Well, and the reason is doing my research, the black box uses tons of G-code doing CNC. I did never even anticipated this. But my Pi 3, I think it is, just would not keep up. It's not really technically supported, though people have been doing some of that work. Yeah, so this guy, super small form factor, it'll fit in the case. The only part that I don't like is a giant big old power brick. So I'm gonna figure out that. And if the output is 24 volts, we're golden. And I don't even really need this. I could probably hotwire this thing in. Not even seen it. It doesn't matter. We'll get around to it. We have an on-off button. This was initially going to be for my table saw over there. I didn't end up using it because one reason or another. This is going to go in line for our primary power that comes into the unit. This power strip is going to feed the 24 volt power supply. It's going to feed the on-off relay controlled power adapter that is going to be used for the CNC, or for the actual router to turn on and off. And I am not sure where I put that. After that, this is going to be a emergency stop. The part that I'm not crazy about is there's no physical way to tell the black box, okay, I'm hitting the stop button, and it pauses the code. That would be really nice if there was a physical way to do that. I have not found it. If someone knows about it, let me know down in the description. But what I will be doing is I'm going to be wiring this in line with the hot leg to the black box. And this guy, because of where this is going to be positioned, won't be sitting on top of this. This will end up being sat on top of, probably build a mount for it, and then put a little enclosure and a lot of dielectric grease on the bottom of that, so nothing arcs. That's everything I can think of now. It seems simple, but you never know. Alright, so let me show you what my layout idea for this is going to be in the box. So this is kind of the overall layout that I'm going for. We're going to have an 80mm fan inlet from the bottom. The reasoning is if we have wood chips flying around up over here, I don't want it to be trying to suck that in through a filter. The power supply is going to be mounted up on the side like this. The 24 volt or 24 volt to 12 volt converter will be mounted there. We have, I don't know if you can, yeah, you can see it. There's an exhaust fan there, so air is going to be pulled up through the hot bits and out through the top. The computer is going to be mounted down here, and then the 12 volt board for the fans will be right here. So that's kind of the basic idea. That should provide me a lot of extra room, and more than likely I'm going to have to redesign this. I'm going to have to drill some holes for those. I'm going to have to drill at least 2 holes, one for the power line coming out through the bottom, and one for all of our interfaces that are coming through here. That's the goal. Anything that's getting mounted down to this board, if it has mount holes, I bought a whole bunch of small screws that should work. We'll have to see. This black box does not look like it's lining up, so I might have to drill holes and washers and stuff like that. The things that are going to be mounted up on the side, specifically this and this, I am going to be using more of my good friend VHB. You guys know how much I love that stuff. So that's the idea. Let's go ahead and start getting the holes drilled out, and we'll start getting things mounted. I want to apologize. I didn't get a lot of footage on me building the box, mostly because I didn't feel like it was all that interesting. So here's a quick clip of the work I did. As for attaching things to the backplate, like I said, I was going to be using screws. I did not. I ended up using VHB for attaching everything. And it's still holding on there really tight. So, good stuff. Okay, so I'm going to end it here for the night. We got the power supply mounted. We got the fans drilled and cut in place. We got the power strip attached in. I'm going to put the black box over on this side. My thought is, if I'm getting into this box, chances are it's for this bad boy. So I might as well make it easy on myself. So swing it open. Sure, there's going to be a bundle of cables, but I'll deal with that later. I need to check to see if that VHB is conductive. If it is, I'll have to find a different way to mount this. If it isn't, well, I don't know. Maybe on the side over here. What do you guys think? Well, I'll have already done it by then. So, a few things that I want to just mention real quick about the air in this box. I'm going to run this as a positive pressure case versus a negative pressure case, because I will not have an equal pressure case, most likely. I'm going to have open holes in the bottom where all my cabling's coming out of. I'll probably do my best to try to seal those up, but it won't be perfect. This fan is going to spin at full RPM all the time, while this one's going to be temperature controlled. I don't really think it's going to make much of a difference, but this will spin slower. This will actually create a positive air pressure and it's going to blow air out through the bottom. What that'll make sure is there's no dust ingress through those holes. At least that's the theory. But anyways, this is a good stopping point. We got the big blocks mounted in. Probably mount this guy in. I don't know. What do you guys think? Right there? That kind of looks good. Probably lower. Probably right around here. So I can get these cables in for the input. Yeah, like that. Probably. Or if I'm feeling froggy, I don't know. I'll figure that out later. Yeah. That's a good place to go. Alright guys. See you tomorrow. Hey everyone, just a quick update. I know I've been doing a lot of showing you what I've been doing, but frankly the parts that I've been doing, you don't really care about the seeing. So, what I've done is I got a couple shelves installed. I got some particle board over here to build the spoil board top, which I haven't done yet. I got this panel built up. Basically, it's 22 gauge sheet steel that I bought over at one of the box stores and bent the edges to give it a little bit more rigidity. I'm going to end up screwing it up top and bottom, putting it in place, or at least the top. I don't know if I need to do the bottom, but this is going to be the master on-off switch for the whole unit. So you come over here, you'll hit the button, you come over here, fire up the computer. Eventually I'm going to put an east button here that you can hit. That will be used for turning off the Arduino or the black box. That, as right now, if I hit the master on-off button, it'll kill power to the whole unit, which means that the Windows 10 computer goes dead with no power, which is okay, but shouldn't be doing that to a Windows 10 machine. It'll corrupt itself. What do I have, or last bit, is I've been making those standoffs, and I've been building them for these micro switches. These are our limit switches, or homing switches, and they'll just simply screw in like that, and then I will bend this a little bit to fine tune it. As this comes back, it'll just kind of push against this. I'm not worried about the side flex on it. What do I have left to do? I have 4 more brackets to make. 4 more brackets to make. 2 for the x-axis and 2 for the z-axis. Again, I have no clue how I'm going to mount the z-axis. That's going to be troublesome. I still have to drill a hole in the bottom of the box to get all the cabling in. I need to do my cable routing. Gotta cut the spoil board. And then I can start tuning. So that's currently where I am on this project. Yeah, I'm just trying to get this done, and hopefully this will be the last video for this unit. That's a long list. Don't know if I can make it, but we'll try. Okay, I got the giant button wired up. I bought a 25-foot extension cable, 14 gauge, cut it and spliced it in there. I've also grounded the whole thing, the whole chassis as well. So you can see it comes through here. Well, you can kind of see it comes through here, around, back down to the box. I finally got it mounted. So let's see if I let the smoke out. So, almost done inside. This is where that little PC is supposed to go off to, right there. But, yeah, need to get the limit switches hooked up, control over the router, turning on and off, and then start tuning. Welcome back. So, failed you guys. Didn't get this thing done like I wanted to today. Just so many small parts. So let's kind of go through parts of these, and we'll show you what I've done and where we got to. Unfortunately, there'll be one more video, but that will be the last. I promise you guys that. So first thing I did was find a place to mount my master on-off switch. This guy will control the entirety of the box. So the computer over here that'll end up running the black box. So if there's an issue, master shut-off switch right there. Why did I put it there? Because this side of the CNC is going to go up against a wall. It's actually going to go where that buried radial arm saw is, and that guy is going to find a new home. Alright, so this panel I made, picked up some 22 gauge steel from big box store. It's easy to cut with some snips. I cut it, I bent the edges to give it a little bit more rigidity, screwed it in. The power is a 25-foot extension cable that I cut in half. The whole chassis itself is also grounded from the power cord. So there's my ground. You can see them both coming from underneath. Now I'm pretty sure you glanced it, but limit switches. Not 1, not 2, not even 3, not 4. But 8. So I put them on each rail or each ball screw because I don't want it to kick it off. This has the potential of racking and kicking the whole thing off. These guys, not so much. So I'm not worried about alignment. The alignment on these will never change. The alignment on these could change. So that's why we have limit switches here. The black box that I used says that you can wire these as normally open or normally closed. Their standard is normally closed, so I did normally closed. Or, excuse me, normally open. Ignore that. The black box standard is normally open, not normally closed. The difference is open means it's open circuit, there's no electricity going through it. Normally closed is there is electricity going through it. These are normally open. So what happens is when one of these hits a switch, it closes the circuit, tells the box, hey, by the way, the circuit value has changed. Do what you're supposed to do. So that's what those are for. Each axis, all of their micro switches are wired in parallel, which means any one of these can trigger and they will all send the proper signal to the box. The other option is if you were to wire these as a normally closed circuit, you would then have to wire them in series from one to the other to the other to the other. Just how electricity works in that regard. So we got these mounts built. Again, this is just out of that 22 gauge sheet metal. Ran all the cabling the cabling. I also built the standoffs to hold the cabling up. So we have enough slack to go all the way across. Then we have enough slack here for both the X and Z limit switches and motors to run full length of the chassis. Everything comes down here as a managed mess. Don't worry, I will snip those off. I will snip those. You know what? I'll do that right now for you because I know it's getting to you. 1, 2, 3, 4, 5. There you go. You feel better? I know I do. All right, so let's come in here. So the little computer that I was going to run in here was supposed to go right here. Well, it won't take an OS. Believe it or not, I know a thing or two about computers. I can't get it to take an OS. I'm not sure why. I just kind of gave up. To control this, I went online and I found it's an HP EliteBook 800 Mini. I don't think it'll fit in this chassis still, unfortunately. It's just going to be too big, so I'm going to have to figure out how to mount that. But the reason why I didn't end up going with, if you guys remember, the Pi is because lack of memory. If you're running 10,000 lines of G code on this thing, it's just going to bog down. Everybody was saying that this board, or this guy, just doesn't play well with a Pi when you're running tens of thousands of lines of code. And I don't know if I'm going to, but I don't want to risk it. Anyways, so I got all my cable management done. I've even labeled these, the limit switches on each side. They all connect up in here. We got all of our motors connected. So what's left for the project? So as far as I'm aware, I only have 3 things left. 4 things, maybe. I don't know. I have to tune these because I know this guy is out of whack. So I got to tune this up and down. I have to tune all my limit switches so they will stop exactly where I want them to stop. So tuning's first. Second one is going to get spoil board mounted. I'm not 1000% sure how I'm going to do that. I have some riv nuts, but I don't have a riv nut compressor, and those are like 60-70 bucks, and I already spent way too much on this project to begin with. I don't know. I'll have to think that one through. And then getting the computer to run this. For now, my laptop will run it more than fine, but my big concern is my laptop will get dusty, and I don't like that. So those are the next steps for this guy to get it operational, get it running. You may not see that for the next video. I have another project in mind that I need to get done that's kind of in relation to this, but also I'm tired of doing these videos. I know you guys are probably tired of watching me tinker on this thing. This thing's taking me months. Isn't it how it goes? The last 20% always takes 80% of the time. Whatever. So that's where we are. I hope you enjoy. If you have any questions about this build, if you have any concerns, or you just want to say hi, feel free to leave a comment. I'm happy about that. I do my best to reply to everybody. Yeah. Thanks so much for watching. You have a great day.